Genes linked to self-awareness in modern humans were less common in Neanderthals' brain networks for memory and planning may have set us apart from Neanderthals, and chimps. Neanderthal woman was recreated and built by Dutch artists Adriaan Alphonse Kennis. They used replicas of a pelvis and cranial anatomy from female Neanderthals for authenticity. The Neanderthal is shown in comparison with a modern woman. Our creative powers may explain why we have been around for the past 40,000 years and Neanderthals have not. Also, traits that stand out in modern humans may provide clues as to why we have maneuvered a helicopter on Mars while chimpanzees have only engaged in the most basic tool use. We bear a trace of Neanderthal legacy in our genome, a bequest from ancestral interbreeding. But some experts argue that, on balance, the sharper innovative capacities of Homo sapiens contributed to pushing our hominine cousins over the extinction cliff. In the absence of any living Neanderthals to interrogate, a combination of clues from gene analysis and the archaeological record must fill in the blanks of this enduring mystery. Findings published in 2019 have tied the learning and memory necessary for creative thought to three brain networks. These networks, which govern our emotional reactions, self-control and self-awareness, are associated with a suite of 972 genes identified in those studies. The same research group has now compared these genes among chimps, Neanderthals and modern humans. Across all three species, the results show an overlap in emotional reactivity but a divergence in genetic sequences governing self-control and self-awareness. In a paper published on April 21 in Molecular Psychiatry, see Robert Cloninger, a psychiatrist and geneticist at Washington University in St. Louis, and his colleagues report that modern humans also have a set of 267 genes from the larger set that the other two species lack. Most of these sequences are devoted to regulating genes in the self-awareness network. That close regulatory oversight of being able to define and recognize the self could contribute to the creative flexibility that allows humans to adapt to the most trying environments, the researchers say. They speculate that an especially inhospitable climatic period in Africa 320,000 to 200,000 years ago drove these adaptations. In part, thanks to self-awareness, we can summon autobiographical memories, go on mental journeys to the past and future, and make predictions based on knowledge that lets us devise innovative plans. A conscious awareness of who we are gives us the ability to tell ourselves apart from others and put ourselves in their shoes. In short, it enables us to be creative in our thinking. What we see is that under ecological pressure, there was this transformation to rely on ingenuity and looking out for one another through better communication and a greater capacity for identifying with one another, Cloninger says. The resulting social support networks may have contributed to resilience to injury and disease, leaving H. sapiens better equipped to innovate out of dire climatic straits and live longer. These features, he says, could underlie what some view as characteristics of modernity: narrative art, socially oriented behavior, interaction with strangers, and healthy longevity. For the new study, Cloninger and his colleagues considered the 972 gene sequences associated with the three brain networks they identified in modern humans. When the researchers sized up how much of the gene set belonged to each species, they found the biggest differences in those for self-awareness, intermediate differences in those for self-control, and small differences in those for emotional reactivity. Chimps and Neanderthals differed the least, especially in genes in the emotional reactivity network. Setting aside 54 genes unique to the H. sapiens emotional reactivity network, the three species shared 72% of the genes associated with emotional reactivity, suggesting something in common when it comes to emotions among great apes. Neanderthals fell between humans and chimpanzees in their number of genes associated with self-control and self-awareness. They had more genes devoted to self-control, compared with chimpanzees, 32% versus 25%, which might relate to differences in emotional expression between us and our closest cousins. Neanderthals also had more genes allotted to self-awareness than chimps, 38% versus 33%. When the authors excluded genes for human personality present in chimpanzees and then compared the two Homo species, they found that H. sapiens laid sole claim to 67% of the genes associated with self-awareness, 63% linked to self-control, and 59% tied to emotional reactivity. Modern humans had solitary dibs on 267 of the genes overall. Of these, more than 90% are devoted to turning protein production up or down, most of them in the self-awareness network, as if evolution drove the addition of many fine-tuning dials for this network that enabled delicate calibration. These findings lend support to the idea that higher creative capacities in anatomically modern humans may have evolved in Africa under powerful climatic stress and allowed them to outpace Neanderthals when the two species met, the researchers write in the study. Cloninger says that he and his co-authors, who include anthropologists, are arguing that by the time H. sapiens left East Africa, they already had the creativity, longevity and sense of community that gave them the advantage to displace other hominids. The results may also imply a more rapid appearance of these adaptations than some experts have projected. Asbjørn Pearson, a professor of anthropology at the University of New Mexico, calls the findings really fascinating, but says that he would have expected smaller differences between humans and Neanderthals. The hominine lineage split from chimps around 6 million years ago and from Neanderthals around 500,000 years ago, Pearson says. That gap between Neanderthals and us is only about a twelfth of the time between chimps and us, he points out, yet much of the evolution that seems to characterize modern humans seems to have happened after the split with Neanderthals. The results indicate a burst of changes rather than a slower accumulation. One puzzle, says Vagesh Narasimhan, an assistant professor of integrative biology and statistics and data sciences at the University of Texas at Austin, is what a reverse analysis would show if researchers derived the gene set from Neanderthals instead of modern humans as the starting point for the comparison. It could be that there is another set of genes responsible for cognitive traits in Neanderthals that are not in humans, he says. If it were possible to link Neanderthal behaviors to genes, as researchers have done for human behaviors, he says, you might find that Neanderthals are the ones with a special bunch of genes that are not present in humans and chimps. The authors acknowledge this issue as a limitation in their study, writing that they cannot exclude the possibility that Neanderthals could have had unique genes driving their cognition. Although H. sapiens and Neanderthals clearly had their differences, Neanderthals are still remarkable. They're humans, they have large brains, and they're adaptable, Cloninger says, slipping into the present tense. I've always been impressed with what the Neanderthals can do. Thank you for watching.